That's it. So, hi everyone, Wesley here. Welcome to the final episode of my solid series in C#.net. And today we're talking about the Dependence Inversion Principle, one of the most powerful principles in software design. So, and yes, it is a big deal in modern .NET development. So, the dependency inversion principle says high level modules should not depend on low level modules. Both should depend on abstractions. That means stop hard coding your dependencies. Let your class depend on interface, not implementations. So let's see a quick sample here that violates the DIP. So we can see now I create this mail service. So I have this mail service which just send, and I'm sending a message here. I will remove these dots. I don't know. No, let's keep this. So this just send, and then I have my notification manager, no DIP. So this notification manager in this constructor it will create this is creating this email service we have here, and then it sends. And here is the problem. So at first glance this looks fine, but here's the issue. Notification manners is directly tied to a mail service. It can't use anything else. No SMS, no push notifications, no tests without this mail service because we are setting this up on the constructor. So it's fixed. So this is exactly what dependence inversion principle wants us to avoid. A high level class like notification manager is depending on a low level class, a mail service. If you ever want to change the notification method, you have to edit the manager class. That's bad design. So let's refactor this. Let's fix by introducing an abstraction like an interface. This interface, so I will create this. We have oops, I notification service. No, public interface, and you have a void send only with the message. Oh, and I forgot to show something. Let me run here. So we would choose the fourth one. So we have dependency inversion principle, no deep sample, sending email. I hope this email finds you well. So here we have the notification, like creating the service here, and then the mail server is sent. And we have my deep sample when I'm just creating this the notification manager and then notify. I'm notifying by how? I'm notifying this by email. Only by email. So now I just started my my chains here to create this interface, and then I will change the mail service. Now the mail service have this implementation from an interface. I notification service, and we have this send already done here, the notification service. And then we need to create another notification manager because this one is no DIP. And now I'm creating a notification service, a real one with DIP. We have this notification service, public key, and all right, we need a constructor. And in this constructor, I will receive an I notification service. It will be any service. And we need to create a private read only service, private read only notification service. And we'll have notification service, saving service, and then notify. So public key void notify with the message. And now I don't need to care about which service is an email, is an SMS, a push notification, whatever. I don't need to care about the service will send, and that's it. So if I try this here in my deep sample, I will receive almost this, but is the IP notification manager notification service. Oh, I forgot here. Notification service. But now I'm injecting the service one, the low level service. So could create mail service, receiving the mail service and send this here. And now I will send the messaging. This is a message from an email. Let's check this. So sending an email. This is a message. Sending an email. This is a message from an email. And now it's easier to change this. I could add something like uh, SMS service. And this comes from an interface notification service. Let's implement this interface and console write line send SMS with this message. And now I could use like this. So we have the notification here. Now I will create a new one with SMS service, SMS service, SMS service, and I could use the same thing here. Notify SMS with the SMS service. This is a message from a SMS. I could just run in here. Let's check this. And it's working. So sending an email. Oh, I just forgot something here. Let me just SMS service sending SMS. No, this is right. SMS service in a deep sample. SMS service, send a message from SMS. Oh, because I create this one. All right, I just forgot something here because I'm using the same service here. Instead, this is this. So let's run it again. Let me close this. So, all right, sending an email and sending an SMS. This message, this is a message from an email, and this is a message from an SMS. And that's our extraction. And all right. So now this class can work with anything that implements identification service, including mocks, tests, or a new delivery channels. And in the real world, this is what powers dependency injection frameworks like building service container in ASP.NET as ASP.NET Core. It also allows unit testing. This is a pretty huge one. Mocking and replacing dependence with zero chains to your high level logics. So let's wrap this up. DIP helps us to write code that depends on contracts, not concrete details. It's increased flexibility, testability, and reuse. It's the foundation of the modern .NET architecture. So that's it. We have now seen all the 5 principles of Solid in .NET and C Sharp. Single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. Let me know in the comments which principle was your favorite and which one you are already using in your code, probably all of them. Thank you for following this series. Don't forget to like, subscribe, and check the GitHub repo below. And that's it. Now I'll be back on now in my design patterns series, and I'm starting another series talking about cloud, and we will talk about Azure. And see you soon.